purpose of this meeting is to do a live laboratory where we cover two design patterns that we discussed during the course, which are the state machine and the command. So the state, like a summary, it's a smarter strategy because the object can change its own state, and we will see how we implement those two ways that we have seen during the course. And the command is the classic solution for an asynchronous execution, which means I want to execute a function, but I don't have the assurance that it will execute now, so I don't want to wait for it. And I want to be sure it will execute, but it doesn't matter when. I know it will execute. So let's see how we can implement or encapsulate this promise or a future, because this mechanism is available in many languages and it has different names. Okay, so before doing that, let's see a scenario which justifies the two patterns. So we have our example, which covers, let's say, the virtual scenario where we develop a multiplayer game with superheroes, and we have seen different issues and how patterns can be used to solve them. So these are the last two requirements that we want to implement. So let's go through those two. So the first one, it's about game characters' actions which are affected by their state. So generally, in order to determine that you need a state machine, you need to see in the problem that the object, which is the main subject of the story, it's able to make decisions, it's able to change its behavior by, let's say, reacting to different external or internal events. Okay, so let's see if this is also visible here. So it says that game character actions are affected by their state. So this says that the object behavior is influenced by the state of the object. And remember, we know this from OOP. When we say the object state, we always refer to the all the values that the object attributes have, because this is the state of an object. So if you have a student class with name, age, and faculty, and you have an object and you ask what's its state, you can say that object state is given by the fact the name is Anna, age is 21, and faculty is cybernetics. So this is the state of that object. And when the object state changes, maybe Anna is transferring to another faculty, this will happen, which means the attribute, one or more attributes, will change their value. Okay, so let's see if in the next details we have the assurance that the object actions are determined by its state. So the gameplay is different, the action effects are different, which means if in our game we have different visual effects for running, walking, whatever, because maybe the object state is different, maybe it's under a spell or has a shield or whatever, we will present different visual effects. The way the superhero moves, is affected by its state. And again, here we get a hint that here this refers to how many life points the hero has. So we will focus on this one because it's easy to implement without too many details. So here it's saying that the superhero will move in a different way depending on how many life points do we have here. And we can extend this example further. And the second problem, which is the command, and we will implement these examples one by one, is about this. The game client must perform tasks in the background without interfering with the development of the game, without blocking or slowing it down. And you see, this is the classic, one of the classic examples or scenarios where you need asynchronous execution of actions. because this is what happens. You have a game which runs, so I'm playing the game, and behind the scenes, the game is doing background tasks, silent updates, backups, whatever, bringing new content. So there are many reasons to do that, but I don't want to interfere with the player experience. It's not like you are in the middle of an action, and then the game will pause, or it will show pop up saying, "Hey, do you want to back up now?" in the middle of the action, right? No one will like this. So this is the classic scenario for asynchronous commands. The problem will always say that you do something in the background, something that you don't want to block main action or the user interface or whatever. Okay, and here we get some different background actions: customer data backup, receiving updates from for the forum, update 3D models in silent mode, and so on. And the requirement: the solution must be found through which this task can be executed without affecting the execution of the game. Okay, and again here it says that, hey, it doesn't matter in which order you execute those actions. I don't care. I just want to be executed without interfering with the game. So here we have a command. Okay, so this is the command, and here is the state machine. So let's go through this. You already have these stories. You have them here in the README of Laboratory 11. So let's open a new one. So let's define the package that we would use. So CTS. Okay, so again, we are in the patterns section. And again, for didactic purpose, I will name the package with the name of the pattern. So here we are talking about state. Okay, and what we want to do is to manage the superhero state, right? So what we want to do is to have this class hero. Okay, and we want to design it as a state machine. And you know from the previous course how to design a diagram showing different states of an object. So basically you start with that, you draw that state diagram, and then you do the implementation. Okay, so I want to make this hero object, future object, a state machine. So this is a design that we start with, which means we implement the class by following the design pattern principles. So let's open the diagram. Let's see how the state machine should be implemented, because we need to start with this schema. So let's see where is the state machine. Here it is. Let's zoom on it. The state machine. So just ignore the label because it's not right. So this cheat sheet is created by students for students. So if you feel that someone is trying to trick you, these are your former colleagues. The diagram is right. Okay, so just ignore the label. So let's read the diagram. So what do we need to do? And we have seen this also for strategy. So we need to define a framework of, let's say, in this case, I will not name them strategies. I will name them states. So we need to define this framework of states. Okay, so we start with an interface or an abstract class of a state. What means the state of a hero? And generally here, we can define one or more actions which can influence the actions or the state of the hero here. So let's define this interface. And remember what I told you at the course, that a big difference between the state and the strategy patterns is that here, for a state machine, because the diagram is the same, there is a difference which is not visible in this diagram, but you need to be aware of. And that difference is about the fact that here in these states, you need to be able to change the current state here in the object, which this is not a requirement for strategy. So the difference between strategy and state is not in the pattern diagram. Okay, it's in the logic of the pattern or the problem. So here we need to take this into account, because I told you at the course that there are two ways to do this. To change from this location, to change this reference here, to change the current state of your object, you can do this in two ways. One way is to pass to this action, this method, the reference to the object for which you want to control the state. So this is one possibility. And the second possibility is to pass to this object the reference to the context, to the object which is handling its state. So when we will create this state object here, through the constructor, we can pass the reference to this object. Okay, so you have two ways to do this. Now, if you analyze it, and we had our own conclusion at the course, from clean code perspective, I would say that it's much more cleaner to pass the reference to this object through the constructor of the state, because then you don't need to pass it through the method parameters. And the method parameters here, if this is a method similar to something you have here, they will be similar. So it's not like, why do I need to pass the reference to this object here in this method? Okay, so it's much more cleaner. But also it has a disadvantage that if you miss that moment when you create this state object, you don't see that you get the reference to this object. Okay, so I will try to implement both for both patterns. Okay, for both scenarios, to show you how that could be done. Okay, so I will implement both ways to pass the state, the object reference to the state object. Okay, so let's, from the diagram, we have seen that we need to start with the framework of possible states. But again, I need this class hero, because I need to pass the reference to this hero to the methods inside that framework or inside the state classes. Okay, so let's define an interface. So this will be iHero state. Okay, so this is the state of the hero. Okay, and here let's define a method, for example, for move. Okay, so we have this, and also let's define another method, heal. And here I will use the approach by passing the hero reference through the state action. Okay, so this is one of the two choices. So here I will say, how many points do you want to heal? And here I will pass the reference to the hero. Okay, and we also need a method which will change the state, including heal will change the state, because by healing we can change from wounded to normal, right? So here I will also have something like get hit. This will lower the points, where I think it's better to leave this in the class, because I want to show you that we can change the state from inside the object, and this will be the method that we will use, or we can change the state from inside the state object. So we have move, we have heal, and heal gets this one here. Okay. So let's define a normal state. So new class. So this is a class, normal state, which means everything is normal. We behave in a normal way, let's say. So here, we need to implement those two methods. But I said to you that one way to pass normal, sorry for the typo, is to use the state object constructor. So that will be done like this, hero, hero. And here, let's generate the constructor. Source, generate constructor using fields, hero. Okay, so in this implementation, you have both ways that you can use in order to change the state of a hero from the state itself, because this is a class which be a state, will be a normal state. And here you see we get the hero through the constructor, which means we can, using this reference, at any moment here in this class, we can change the state of that object. And I will show you how we can do here. But also here, we see also the second option that you can use in order to make the state be able to change the hero state. So in the end, you should choose one way that you like, okay? Or you can have both, depending on what you want to do. But like I said, both are correct. So either like this is correct or like this. Now, personally, I prefer this one here because a state object is dependent on the object itself, okay? Because these objects, they have no reason to exist without being associated to a hero, right? So that's why I prefer this approach versus this one here, because here, when you say heal, you see the points, which makes sense for heal as an action, but also you see the hero. So this doesn't read too well, okay, in my opinion. It's not so clean. But both options are right because none is better, okay? None is perfect. So what's the issue with this one here, with this approach, with the hero here? This has a big disadvantage that when you create a normal state object, you will link it to a particular hero, right? Because let's imagine we have a game with multiple heroes, Superman, Batman, whatever. And if you create a normal state and we choose this option, it means that when you create a normal state, you need the reference to the hero. But this, it means that when you create a normal state, you will link that object to Superman or to Batman or to another hero. And that means that if you want to have a normal state for all your heroes, every time you create a new superhero in your game, like Batman, Superman, you need also to create a normal state. So this will create a lot of state objects because each will be linked to a particular hero object. And you can't reuse them. So this is the big disadvantage of this approach. Okay? Now, this issue does not exist if you choose this option, because here, if you pass the hero reference through the method parameters, so you don't have this anymore, it's like this, it means that you can create a normal state which you can reuse for all your heroes. Because in the end, you just need this method. And you can reuse it because here you get the hero reference. So that's why I'm saying that both options are correct. They have advantages and disadvantages. So they are kind of opposite in terms of advantages and disadvantages. So you need to choose the one you like or I don't know, depending on other criteria, the one that fits. But you need to be aware of the two ways to do this. Okay, so that's why here I'm showing you both. Okay, so we have the normal state, which does this. So what it means that in a normal state, the hero moves normally, moves for distance. Okay, so we move normally. Now, for heal, what we want to do? We want to increase the life points of the hero, right? But we don't have a method to do that. So let's go here into hero. So let's switch to hero. So here, let's define life points. Okay, let's also define a string name. Let's generate a constructor. Okay, and let's have here public add points. Okay, and here I will say void. Life points plus equals points. Okay, and we need another method to get the points. Which returns the points. Okay, so we have this. So having these two methods, we can go back into normal state and we can implement heal. Okay, so I'll go here, and for heal I will do this. Points. Okay, and now we said, hey, this is a method which can change the state of the hero, which means, for example, if the hero get a hit and the life points go under a value, then it will be wounded, right? But if the hero heals himself and the number of life points go above that limit, then the hero is normal back. It's healed, right? It can run normal. So if we are in a normal state, it means the hero is already normal, right? It's not wounded. So we don't need to do anything extra. But in the next state, which will be wounded, then it will be interesting, because if you are wounded and you heal, then we should be able to change the state of the hero back to normal. Okay, but we don't do this here, because if this code is executed, it means we are in the normal state. So it doesn't make any sense to say, hey, if number of points of the hero is above this limit, let's change the state to normal. Yeah, but we are already in normal state. So that will be inefficient, because we just create objects and nothing will change in the game. But in the next state, it's a different story. So let's define the wounded state. Okay, so this is another state of the hero, because implements hero state. Okay, we can have both approach, if you like, just to show you. So hero source generate constructor using fields. Okay, let's implement the two methods. So now again here we will see a difference here, because if you are wounded, you can't run anymore. So you move slowly is slowly for, and let's say because you move slowly, you can't go the entire distance, right? Because you're wounded. And we go only half of it. Okay, so you see I have a different action here, which is different than move, than the normal move from normal state. And here, let's change the state of the object if that's the case. So we still do this, not this hero, sorry, because I'm using this hero from here. Add points. And now we need to check if the life points, the number of points of the hero are now above the wounded limit. It means we need to change the state of the hero. So how do we check that? We can go back into the hero class. So we can go here and we can say this: public static final int wounded limit, okay, equals, let's say, 50. If you are above 50 points, you are normal, but if you are under it, you are wounded. Okay, so I will go back in. So I added this limit here because I need to check it. So now I go back to wounded state here, and here I'll do this: if hero get points above or equal, then hero dot wounded limit. Now, and let's put a comment, change the current state of the hero. So we say hero dot, but we don't have the, sorry, we don't have the reference to the state. So we were just building the framework of possible states, but we need to go back and implement this part of the schema. So let's see what we will do next. So you see, right now we have this part. We have the iHero state, and here I have the normal state, and here I have the wounded state. But here I have this one-to-one as a relation because I have this state here, and again, I need here a method which will allow me to change the state of the object. And here I have the reference which will link one of these two. So this could be normal state, this could be wounded state. Okay, so let's go back to code and let's define that in the hero class. So here I will say this is the state reference, I hero state equals null. Okay, and I need the setter, but let's put it somewhere downward here after the constructor, or you can generate it, it's faster. So source generate getter and setters. I want for state set state iHero state. Okay, which is this. Okay, so now I have the possibility to change the state of the hero. Okay, so if you implement the object and you don't have this, you don't have a state pattern because you miss this part. So remember, when you implement the patterns, always take time to validate them because you have the UML schema with you at the laboratory test. Now, if you want to use it, it's your choice, but you're allowed to have it. So always take 2 or 3 minutes after you implement the pattern and make sure that everything which is here is in your solution. Because if you miss any of these details, you don't have a state pattern, right? So I don't know what's that. It's a state pattern wannabe, but it's not one, and it will not work properly. So yeah, this is mandatory because here it is, the relation between the object and the state framework. Okay, so now we have this here, and we have the possibility to change it, which means I can go back to wounded state, and now I can do this, hero, set state, new normal state of hero. Can you see it? So right now, from the wounded state, because we have this reference, I can, in these conditions, so you need to decide when this happens, or it could happen all the time, depends on the story. But what's important to understand is that in a state pattern, this will happen. A state object can change the current state of the object itself. And here it is. And like I said, there are two ways to do that. This is one way, which means you get the hero reference here and you use it here. Or if heal does not receive this, but you have this here, then here you will say if this hero get points and so on. Okay, so you either use this reference, which you got it to the constructor and you use it here, or you use it here. So in order to make a difference, I can say input hero just to show you the difference. Let's do this because they both have the same name. So this will be the approach like this, or so alternative, if you use the hero reference attribute, which means this exact solution will look like this. This hero, again, you should choose one. Okay, now having both, it means you are not decided which you like more, but normally you should you should choose one and use it. So this will be the alternative, okay, because you have the reference here and you got it through the constructor. Then what we have here can be written like this. Now, logical is the same thing. Technical is different because we are using different references. But again, having both can be misleading because you see, if you have both, and like we had here initially hero, you can easily put by mistake this dot hero, which means on this line, you will use this one here, not the one you receive here. So that's why having both is not okay. This will be the way you will implement the hero. So now I have heal. And now let's finish the hero class because we have two states, wounded and normal. So what I want to do here, because generally the client will interact with the hero, not with the states. So the client will need to have a way to move the hero. So again, here I can have public void move. Okay, so what we do here, we don't do an implementation, we use the states. Right? That's the purpose. So here I will say if this state different than null, then I will say this state move for that distance. So you see, I delegate, I do a callback to the state, okay, because the state knows how to move the hero. Okay, let's say I have heal. Again, I will do the same. If this state different than null, let's heal this one. Okay, and depending on the, depending on the current state, you heal in different ways. Heal. No. Here, what's the issue here? It needs the reference. Yeah. You see, that's why I don't like this approach. But again, the other one is not also perfect. So is this, because you pass the reference to this hero, which is the one which calls heal here. Okay, and then let's have a method here which is specific to hero. And here we do this. This life points minus equal points. Okay, if this life points less than hero wounded limit, what do? We change the state. This state equals new wounded state of this. Okay, so when you get a hit, you change the life points. And again, we can also have a game over state. Life points 0. Let's say we have a game over state. So let's do that and finish, and then test this. So I will create a new state. Here I will just go for the option where I get the hero through the method parameters. Okay, so because say this is, it's game over. Yeah, you can't do much. So what I will do here, I do nothing. I will just say game over. And again, when you heal, it's game over, right? Because the game is over. Okay, so now I have also a game over state. So if the hero gets under 0 or 0, then this state equals new game over state. So we have an object. Now, I was just forgetting. Another important characteristic that I said to you that distinguishes a state from a strategy is that strategy is not required. When you have a strategy, it's not required you have an initial strategy. But I said that for state, this is very important. So here, when we create the hero, or here in the constructor, we should set, so that's why I put a comment here, set an initial state. Because you see, it makes sense, because if you have a hero, and let's say we don't ask for life points, because by default it's 100. Okay, so you have a fully healed, fully normal hero. So that's why here you will say this state equals new normal state of this. Okay, so this is another difference between state and strategy. Okay, you have that slide in the course where you see the differences between strategy and state, and this is one of them. So let's test this. So new class, test state. Okay, so let's create a hero. New hero. And you see, the client does not see it, but we know it. Now what do you have? You have a Superman hero, and the initial state is normal state, which means if we move normal. So let's run this. You see, moves normally for 10. Okay. Then let's get a hit. Get a hit. Let's say 30 points. Okay. Initially, we have 100. Let's move this again. So we run this. And now we move another 10 meters, 10, whatever. Now let's get another hit. So now we are at 70. So let's get another 30, which means we go to 40, which is under the wounded limit. So let's move again. You see? It's moving slowly. Why? Because when we got a hit here, the number of life points was decreased below 50, and then we switched the state to wounded. And in the wounded state, move slowly half the distance. You see it? And now we are, so 40 points. Let's get another hit. And let's get another hit of 50 points. Let's move again. What happens now? It's game over, right? Because Superman is out. Okay, so this is the difference between state and strategy. You don't see here the client changing the current state of the hero, like we have seen for strategy, like now I want to compute the average, set strategy average. Now I want to pay with the PayPal. So for strategy, the client, which is you, the developer, will change, depending on different conditions, the current strategy. But for a state machine, the object looks like a smart one and is able to change its own state, right? So here, for example, if I heal it, remember this is, now we are wounded here. So if I heal this one, Superman, let's heal it for 100 points, what will happen? And then we move. And we are back above the wounded limit, which means, what do we do here? We set the state to normal. So if I run the game now, here I will move back normal, and here it's 140 minus 50. Again, I will move normal. You see? Moving slow for 5, moves normally for 10, which are these two lines here. Nice here. Okay, so now you don't need to worry if the state machine is properly designed. And that's why always, before implementing a state machine, you need to take a pen and paper and you need to draw. Okay, you need to draw that diagram, because that diagram will tell you in which conditions the object switches between states. And if you implement that properly and you have all these classes, then you just interact with the object. You don't need to write ifs and anything else. And that's why the state, it's a smarter way of controlling the object behavior without interfering. Yeah, you interfere because you call these actions, but you don't take the decisions anymore, because each state, it's able to switch the object state. So it's much more clean, the solution, okay? Than if you would try to do this with strategy, which is not proper here. Because another difference between strategy and state is that for strategy, you have objects that are basic, simple, and they don't have as an objective to change what they need to do. Okay, like a payment module. The payment module does not have any way to decide how you pay the whatever, the shopping cart. So the user needs to decide that, okay, which means it's the client. So that's why you don't need a state machine for a shopping cart. Okay. So here it is. This is the state pattern. And again, the state pattern, it's something you need to start with. So this is part of the initial design of the solution. Okay, it's not something like you change after 6 months. Okay, so a state, it's something you need to identify in the beginning and design the solution based on that. Like, for example, the opposite will be the adapter or the decorator, which will allow you to change objects. So the decorator is something you can add later in your solution, right? But the state, no, state should be in the initial phase. Okay, so this is the state machine example. So this is the first requirement. Let's implement the second one, and that will be all. So the second requirement is about doing background tasks. And again, this is something that you need to start with. So again, the command pattern is something you need to implement from the beginning, because later will be much more difficult to refactor. So let's see. How do we implement a solution which will allow us to do actions in background without interfering with the main solution? Okay, how we can do this asynchronous? So let's search for this. So what do we need for command? So the first thing that we need to do is to define the executant, which means we need to have, so if I go back to the story here, here you see we need to do some background tasks like doing updates, doing a backup, okay, and other stuff, which means we need to have modules which will do this. So if I go back to the command diagram, we need to start with this part here. Okay, so we need to start with the executors or the executant of the future actions, like do a backup, do an update, and whatever. So this will be the first thing we will implement. So we will have a backup module, we will have an updates module, and the story can go on. Okay, after we have those modules, and they will have an action like do that, do the update, do the backup, then we need to define this framework. So we need to define an interface for the command, okay? And this is actually the class which later will encapsulate the action. What do you want to do in the future? So again, here we have a method which we will need later to execute the command. And when we will implement the command, is what I told you at the course, we need to store the values that we need in order to do that action, like do updates, do a backup. We need a reference to the module which will do that, to the executant or the executor. And then when you implement this action here, execute, here you have the tooltip, which tells you that basically, minimorum, what you need to do here is to use this reference to call this method and pass these parameters. Okay? And in this way, you execute later this action. Okay, so you have the reference to the object which will execute the action, and you have, which is this one, and here you have the parameters, which is the state of the command object. Okay, so let's go back to the, where is that? Yeah, here it is. Please. So let's define a new package. Command. Finish. Okay, so let's define a framework of modules. So the modules are the executors, the executants, right? So new interface, game module. Okay. And here, let's say I have this public void execute task. Okay. And for the parameters, let's say I have this string here. Okay, I can have another strings like main has or something similar. Okay, so let's say I have these parameters. Okay, so let's define two game modules. So new class update module, okay, which implements I game module. Okay, so we need to implement methods. Okay, so what I will do here, I will print a message starting game update. On server connecting server at params. Okay, so this is your update module. Yeah, okay, and now let's do the second module. So we have two executants. We will have an update module and a backup module. Okay, implements okay, again. Okay, and now let's so different message. Obviously, here in reality, you do backup, you do the backup, right? But we just simulate now. Whatever. Params. Okay, so this is the second module. So what we have at this point, we have a framework of executors or executants. So we have this story here from the left of the screen. So now we can define this part here, okay, which is the command definition. So we start with an interface or an abstract class for the command, which will have execute. And here I can start with the, here I can have the real command, okay? So let's go back. Let's define the class, the interface, or we can start with an abstract class just to change. Now, interfaces are more flexible, but again, you can have either an abstract class or an interface. So let's say abstract async task. Sorry, check the abstract. Okay, and here we have this public abstract void execute. Let's see how I name this one here. Execute task. So yeah, do action. Let's just make a difference between them. Okay, so this is the abstract definition of a command or an async task. And now let's implement the async task, which will be the class which encapsulate the parameters for the command, executor reference, and it will perform do action, which is this class from here. This one here. So let's do it. Async task extends abstract async task, which means we need to implement do action. But remember here, you need to encapsulate the values that you need to call when the action will be performed. So what do we need? We need some params. We need the parameters. Okay. Then we need the reference to the game module, which will do this module. And we need a constructor to initialize these two parameters when we create an async task. So generate constructor using fields. Okay. So now we can create a promise or a future action, because now we can create this async task, which will receive these parameters and will receive a reference to a game module, which later will execute this. So here in do action, we do this. If this module is different than null, this module execute task of params. And here it is. This is the moment where this will execute later in order to perform this asynchronous task. And yeah, we just create this, and a task manager later will execute it, or the module itself. Okay, now if you go back to the diagram and remember the course discussion, there is another component here which you need in order to finish the story, which is this one here, the command manager. And this one you see has a relation to commands. Why? Because in reality, you will create a lot of commands. You will create a lot of objects of this class. Like we have now async task. So you need to store them somewhere. So one purpose of this command manager will be to store them. So here, generally, you have a collection. And secondly, you need someone to check if one of these commands can be executed. For example, if you have a slow server, you put this in a queue, and from time to time, the command manager will check if the machine is available, if the server is available, and will execute the next command. So this is the purpose of this component, okay? So it's additional to the pattern. The pattern is what you have seen here, but the manager is also important, because otherwise you will lose these commands. So that's why they put the command manager inside the diagram. So let's implement that command manager and finish the example, and then to test it. So let's add a new class, task manager, tasks. Let's use the plural. Okay, so what do we have here? We have an array list of commands. So what's the base type for commands is abstract, async. Yeah, it's because of the array list. So this is one issue. Okay, so tasks. Okay. So now we have this. Now, because the purpose of the task manager is to manage this collection, what do you need? You need a way to add commands to the task manager. Right? So generally, every time you have a collection, you need to manage it. So it's a common sense. Okay. And then let's say this is a task manager which will execute the commands in order. I need a method which will execute the next task from the queue. Okay, because this is the queue. So what do? We do this if do we have size, what is, yeah, size. If we have values here, which means we have something waiting here to be executed, we take the one from the front. So abstract equals with this tasks get 0. Okay, so you get it. We execute it, do action, and this is the method from the abstract class, or if you choose an interface, and then we remove it, right? Because this is like a queue of things that you want to do and you can't do that right now. So you save them and you execute them. Again, I told you at the course that now here you can implement a priority list. So you get tasks, but they have different priorities. So generally you will want to execute the next task with the lowest or the highest priority, depending on how you use it and so on. Or maybe you have a different logic. But in this case, it's just a simple logic like based on a queue. So let's remove the task from the tasks. Remove next task. Okay. So in this way, we execute in a very simple way things that we saved in the task manager. And that's all. Okay. So we have the command framework, we have the modules framework, and now you have also the task manager. So let's use it. Let's test this. Command. Sorry, I forgot to check the static. Main method. So the first thing that we do is to create the task manager. Right? And now let's say that we create an async task for backup. So what do we do? Manager, add new async task. So location, game folder, and the module. So here we need the module. And again, here you can easily combine a factory to give you the module. And this could be also a singleton registry because you want to store each module in a unique way. So again, you have different ways to use other patterns here, or a set. Yeah. So you can go for a collection. Okay. So I will just go for 2 variables because I have only 2 modules. Okay, and update. Okay. Now here I will pass the backup. Okay, now let's create another async task for update. So manager add async task, new async task. Now this will happen on a different thread, right? So here you have multi-threading in reality because you have one thread for the game itself, the player is playing, right? So you have multi-threading here. Now, I don't want to dive into that, but I just simulate. But if you want to imagine how this happens in reality in parallel, this is the way. You have multi-threading. So this stuff is executed on a different thread other than the game itself. So update. And on that different thread, so here I'm just simulating the player, the game runs. Okay, so I'm on the same thread now, so that's why it's impossible for me to show you the parallelism, but in reality you will have multi-threading. Okay, but here we just imagine. So now we say this manager execute next task. And again, this is in parallel, so the player does not see this. And then we execute the next task, and so on. So if you have here multi-threading, then this will look much more real and much more prettier than what we have right now. So let's run this. And what do we have? You see the game runs. So we imagine that this is on a different thread. Backing up game data, location game folder. Okay, so this happened here when at some point the manager said, let's do a silent backup. And again, the game runs. And then what happens? We start the silent update, which means the game will connect to check for new updates, but this will not interfere with the game itself. And here you have it. Okay, so this is the command pattern. And in this way, you can actually create, let's say, asynchronous actions, which means actions which will perform later, you don't want to wait for, and they will not block your execution, your main thread. But again, with this asterisk, a big asterisk, in reality, you do this on multi-threading.